In this video, we're going to take a look at factoring. So we're going to begin at the very beginning. So let's first talk about pulling out a GCF. So for example, if I had something like 4x minus 12, I could look at the 4x, I could look at the 12, and say there is a common factor of 4. So when I pull that in front of the parentheses, I'm left with x minus 3. So basically what I'm doing here is the reverse of the distributive property. I'm pulling out what's the common factor, what each term, what both the 4x and the 12 are divisible by. In this case it's 4. So this is called the factored form. And generally I'm given the standard form. So when we talk about factoring, we talk about going from the standard form to the factored form. In the past, we've talked about simplifying things as far as multiplying things out, where we go from in the reverse direction, from the factored form to the standard form. So let's go a step further. Let's say I'm given 4x to the third minus 12x squared. So here if I look at the 4x cubed, looking at the 12x squared, I've still got 4 in common, okay, but I've also got the x cubed and the x squared. So the greatest common factor would be an x squared, which would leave me with an x minus 3 in the end. Once again, that's the factored form. So this is about pulling the GCF out. And this is the first step. Anytime I go to factor, I want to check out and see if there is this GCF, if there is this greatest common factor, because it does make things a little bit easier down the line. Next step is to teach you about factoring by grouping. This builds upon the GCF, but in this case, I might have something like x to the third minus 3x squared plus 4x minus 12. In this case, when I have an even number of terms, 4, 6, whatever it is, I can factor by grouping sometimes. By grouping them into two groups, putting a plus sign in the middle, okay, I'll include this sign with this term and put the plus sign in here just to make sure if this was negative, if I put the parentheses after the negative sign, it'll throw off my signs. So easiest thing is just to put a parentheses in front of the sign and then add a plus sign. Out of the first parentheses, I have an x squared that's in common, leaving me with an x minus 3. I keep the plus sign in the middle, and then out of the 4x and the negative 12, I have a 4 that's in common, leaving me with x minus 3. Okay. Now this might look a little bit more complicated, but I can notice that here I have an x minus 3 and I have an x minus 3. So I have x squared times x minus 3, 4 times x minus 3. So just like up here, where I was able to say, oh, 4x and a 12, they have a 4 in common, pull in front. In this case, I have both x squared and 4 being multiplied by this x minus 3. So what I'm going to basically do is the reverse of the distributive. I'm going to pull these out front, and then I'm going to multiply that by what I have left, in this case x squared plus 4. And this here is considered my factored form. So the grouping is about pulling out what's in common, okay? Grouping them in pairs, first of all, pulling out the common factors, and then pulling the x minus 3 in front. Now when I talk about pulling the x minus 3 in front, I just do that out of habit. In reality, it doesn't matter if you put x squared plus 4 times x minus 3 or put things in the order that I have written here. Because it's multiplication, the order is reversible. Now, this has all been hopefully a little bit of a review. I'm going to move on to a method that I call the AC method for factoring trinomials. What I'm going to do is list the steps on one side and then show you concretely what it is on the other side. Okay. So the first thing is to write things in standard form. And for a trinomial, that's going to be ax squared plus bx plus c. So, for example, how this might look, if I take something like 6x squared plus 23x plus c. In this case, the 6 is my a, the 23 is my b, the 7 is my c. So that's how I'm going to kind of refer things. My first step will be to multiply my a value times my c value. So in this case, what I'm going to do is take the 6 times the 7. So in this case, it's going to equal 42. The second step will be to list the factors. So that was the first step. Let's do the second step in red. So the a times the c. The 42, I could have 1 times 42, and I can also have negative 1 times negative 42. Keep in mind the sign is important, so if one of these were negative, this would end up being negative 42. So the signs are very important for this. Okay, I could have 2 times 21, or negative 2 times negative 21. I could have 3 times 14, negative 3 times 14, or negative 3 times negative 14. I could have, so that's divisible by 4, 5, and then I could have 6 times 7, or negative 6 times negative 7. Okay. This third step is to select the factors that add to b, and then rewrite the expression. Okay. And what we're going to do is we're going to, in a sense, split b using the factors. So this is kind of a crucial step where I'm going to take and keep the 6x squared, keep the plus 7, but instead of the negative 20 or the positive 23x, I'm going to use the fact that 2 plus 21 add up to positive 23x. And I'm going to split the 23 into plus 2x and plus 21x. So now since I have 4 terms, my fourth step will be to factor by grouping. Okay. And I'm sorry if I gave you slightly different steps in class. It's basically the same steps, I just sometimes split them up in different ways. So here, factor by grouping. Group the first 2, group the second 2, plus put a plus sign in the middle. The 6x squared and the 2x have a 2x in common, leaving with 3x plus 1. Remember that if, for example, I factor out a 2x, I still have to put the plus 1 there to hold the spot. And then here it would be plus 7 times 3x plus 1. And what you'll notice ended up happening is the 3x plus 1 is in common to both. So I end up with 3x plus 1 times 2x plus 7. Okay. What you'll begin to notice is that these steps look complicated, okay, but as you begin to use it, what you're basically doing is kind of the reverse of FOIL, that this is the result of these two numbers being added together. These are your outer and your last terms in a sense. My plus 2x plus 21x, that's my outer, inner, okay, split up. So it gives you kind of a reverse order way of doing FOIL, in a way to get it from standard form back into the factored form. And as you work on this listing off of factors will become a little bit quicker. Just be careful with sign. Watch your pluses and your minuses. That's the most common mistake here. And what you'll begin to notice is that as you begin to work on this, you'll say, oh, well, plus 23x, well, it can't be the 1 times 42. They're too far apart. And the 6 and 7 are too close. Okay, so let's narrow this down a little bit more. It's always good to have an order, like I did 1, 2, 3, as far as factors. Kind of worked my way up to 6. As soon as you hit 6 and 7, if I were to do 7, it would be 7 times 6. So it would go back in the same order. So you only have to go up kind of that far to know that you list all the factors. Let's go ahead and look at one more. Okay, I'm going to do this one out quickly. So if I look at this, what I would do is say A times C. Keeping track of the sign would be negative 45. Okay, I'm looking for basically two numbers that are 4 apart. So if I'm looking at this, I can tell that it'd be some part of 9 times 5. It could be negative 9 times positive 5, or positive 9 times negative 5. Looking at the middle term of positive 4, it would need to be this value. So I would split into 3x squared, keep the minus 15. My center number would be plus 9x minus 5x. And this is good because I can show you a situation with the negative in the middle. I would put the plus sign in the middle. So I would pull a 3x out of the first, leaving me with x plus 3. And out of the second, I would want to pull a negative 5. Reason being, I look at the x plus 3, know that it's positive. By pulling out a negative 5, I would end up with x plus 3. So then this would factor as x plus 3 times 3x minus 5. And I would get to my answer. Now there are times where using a guess and check method for factoring does become a little bit quicker, especially if it's x squared minus 4x plus 3. Okay, using kind of the idea that the first terms need to multiply to give you this x squared. The only way of getting it is if it's an x times an x. So I've got pretty much my first term. Okay. The next thing I want to check out is my last term. Well, if I have 3, positive 3, the factors will either be 1 times 3 or negative 1 times negative 3. So in this case, I've got sort of the last factors, and then I can try them. So if I put plus 1, plus 3, I want to then check what are my outer and my inner going to add up to. So in this case, I got plus 1x and I got positive 3x. Well, if I add those together, I get 4x, which is not going to be the sign because of this negative sign. So I can get around that by then using minus 1 times minus 3. So my answer will be x minus 1 times x minus 3. Okay. So there's a couple different things that are going on. You want to take a look at what are the possibilities for your first term. And then when I'm looking at the last term, what I'm basically looking for is if the sign is positive for the last term, I'm dealing with a positive and a positive. Okay, sort of here and here. Or I can deal with a negative and a negative. If my last term is a negative, it means that those signs in those parentheses, one will be a positive and negative, or the first one can be a negative and a positive. They have to be opposite signs. Okay, and then once I get that sort of in place and kind of looking at, I'm going to look at my b. Okay, and I have that circled. Whatever sign this is, my signs here need to match my b value. So when I was setting this up, these both had to be negative or subtraction because this was subtraction. And since they had to have the same sign, they had to add up to give me the negative 1x and the negative 3x. If they have opposite signs, the sign of the larger value matches b. Okay, so let's take a look at that. Let's change this and say x squared minus 2x minus 3. Okay, so using my first term, it has to multiply to give me x squared. So the only way of setting that up is an x times an x. Okay, for the 3, it has to be a 3 and a 1. That's the only one way of getting 3. And then in order to get this to be negative, my larger value needs to be negative. My inner one needs to be positive because they end up having to give me a negative. So positive 1 times negative 3 gives me negative 3. So at this point, I've chosen relatively simple ones. Guess and check works great when I have an x squared, when I have a term that doesn't have very many possibilities. But let's say things got a little bit more complicated. Let's say I gave you one of the ones that I gave you earlier. So for example, let's say I gave you that 6x squared plus 2x, plus 23x plus 7. Okay. This gets a little bit more complicated because I don't know if I have an x and a 6x or if I have a 2x and a 3x here. Okay. Judging by signs, this is positive, which means they have to have the same sign. This is positive, which means that these will all be positives. Okay. The other thing I'm not sure about, or the other thing that's good, which makes this quick, is that since it's a 7, the only factors of 7 would be 1 and 7. So I can have a 1 here and a 7 here. Okay, so I've checked the first term, I've checked the last term. Now I need to just check my outer and my inner. So if I check my outer and inner, I've got 6x and 7x, which give me 13x. That's a no. Okay, so let's go ahead and switch that up. Instead of do 1 and 7, let's try doing 7 and 1. So once again, I check my outer and I check my inner, and I got 42x plus 1x, which give me 43x. So I can tell you that no, that's not going to be a possibility. So what I can say then is that this x and 6x does not work out. So now let's look at the 2x and the 3x possibility as my first terms. Well, let's try putting a 1 here and a 7 here. Check my inner, check my outer. I get 14x plus 3x, which give me 17x. It's not large enough, so then I need to go back and change that. Instead of doing 1 and 7, let's try 7 and 1. Once again, check my inner, check my outer. I deal with 21x plus 2x, and I get 23x. So yes, this is indeed my solution, which is what I found earlier. So really, it's up to you which method you decide you'd like to use. I'd encourage you to try using the AC method. Start off using the AC method because it becomes a little bit quicker. The guess and check method you can slide to, particularly if it's x squared. It's relatively easy to solve. Just don't get the methods confused. But particularly something like this where there becomes more and more possibilities, the AC method usually ends up being a little bit quicker. So the only thing left to look at is my special cases. anytime you have your a and your c term squared, so if I gave you something like 16x squared plus 4 plus 16x. Okay. Anytime you notice that your a term is a perfect square and your c term is a perfect square, be thinking of those special cases where the square root of 16x squared is 4x, the square root of 4 is 2. Always check and see, well, what's 4x plus 2 quantity squared? You can always check and say, okay, well, using the rule of the special cases, if I take these two values, the 4x times the 2, and then if I multiply that by 2, I get 16x. That should be my b term, and it is. So right now, without having to go through the hassle of the AC method and guess and check and everything else, I can check, and a lot of times the special cases will be something like this. Okay. Likewise, if I gave you 49x squared minus 14x plus 1. Okay. Once again, this is a perfect square, 7x. 1 is a perfect square, plus 1. What happens if I square it? Same thing, I can check. What's 2 times 7x times 1? And I got 14x. I got my middle term. The only thing I messed up on was that here should be a negative sign, of course. Okay, to get that negative 14x. So that works out. Last case, what happens if I gave you 49x squared minus 16? Once again, this is your difference of two perfect squares. So my answer will be 7x minus 4 times 7x plus 4. The order doesn't matter. Once again, I could do 7x plus 4 times 7x minus 4. It gives me the same value. But this is the benefit of knowing those special cases. If you can recognize your a term and your c term, or if you have a binomial with the subtraction with two perfect squares, it becomes pretty easy to recognize as one of these special cases and saves you some time. So hopefully this video, I know, has been long, but hopefully it'll kind of provide sort of all the background with the factoring, kind of the foundation that we're going to use as far as with practicing.